Okay, so in this video, I will explain how to define and call a function in R. But before creating our own functions, I think it's a good idea to set a clear image of how a function works. So let me demonstrate some functions that are already built in your R before creating our own function. So for example, pi is 3.1415 in R. If you want to round down a number, you can use a floor function. So floor of pi gives you 3, so the number is rounded down. If you want to round up a number, you can use a function called ceiling. So ceiling of pi gives you 4. If you want to round up or round down, depending on the last digit, you can use round function. And you can choose the number of digits. So you can choose 2. So the number is rounded down or rounded to the second decimal place. So this will give you 3.15 round pi I to the third decimal place gives you 3.142. Just some terminology. For function, inputs are called argument. Okay, so here pi is an argument, 2, 3, these are also arguments. Argument is something that you give to a function. Values that a function returns for you are called return or returned value. Okay, so here 3.142 is a value that is returned by a function. Okay, so in a function y equal f of x, x is argument, y is a return or returned value. Now let me demonstrate some built-in functions with a vector argument. There are also functions that accept a vector as an input or argument. So for example, let's say x is random draws from uniform distribution. So R unif 10. So that will give you 10 random draws from the uniform distribution over the 0, 1 interval. So what is max of x? X is a vector of 10 numbers, and max of x gives you the largest element of this vector. So that's 0.98. Let's see here. 0.98 is the maximal component. Similarly, mean x gives you minimal element 0.298 in our case. Mean of x gives you the average of the elements of x. Standard deviation, SD gives you the standard deviation of the 10 numbers. Sort function rearranges all elements in the ascending order, and so on. There are many functions for which the argument is a vector of numbers. Okay, so let us create our own function. Okay, let us define our own function. The basic syntax is quite simple. Let's name our new function f. If that is the case, I write f is a function, so the command to create a new function is just as it is, function, and I open parentheses and write x in it. So here I'm saying that the argument of this function f is x. Then open braces, curly brackets, and the description of the function comes here. I write y is 1000 times x plus x squared. And I want the function to return the value of y, so in the end I write y. And this is it. Okay, I run the code and see this list on the right. So this is the list of all the variables and functions created so far, and we see f here. So function f has been created. To use this function f, let me try in the console. I type f of 1, and the value returned is 1001. So if x is 1, f of x is 1001. If I type f of 2, it's 2004. f of 10 is 10,100, and so on. Now, R returns the value of the variable that appears last. In this case, y. Function f returns the value of y. Even if you omit this last y, the function still returns the value of y. Let me try what happens if I omit this last y, okay? So I erased y, and because I changed f, I should rerun the code. Okay, we don't see it, but the contents of f have been changed. Now, if I say a1 is f of 1, a2 is f of 2, you see a1 is 1001, f2 is 2004. So the function is still working. The function is returning the value of y. But if I simply type f of 1 here, R no longer prints 1001. And this is because we erased this last y. So, if you want R to print the value the function returns when you use from console, you should conclude your function with the value to be returned, in this case, y. Okay? Now, the function name doesn't have to be f. It can be anything. Also, the name of the argument doesn't have to be x. The name of the returned value can be anything. It doesn't have to be y. Okay? For example, suppose I want to make a function to which I give the before tax price, and the function returns the amount to be paid. I can name such function as pay. Again, the command to create a function is function, and this time, open parentheses, this time I name the argument price. Open the braces, and inside the braces is the description of this function. I use z this time instead of y. I can do that. Price times 1 plus tax rate. Let's say tax rate is 0.08, 8% VAT consumption rate, consumption tax rate. And I say return z. Okay, here I'm assuming that the tax rate 8%. And that's it. I run the code. The pay function has been defined, and I can use it, right? Let's say the price before tax price is 1,000. Then after tax, how much to be paid? Run it, 1,080 yen. So if the before tax price is 1,000 yen, after adding 8% tax rate, the amount to be paid is 1,080 yen. So the point here is that the function name doesn't have to be f, it can be anything. The argument to the function doesn't have to be x, it can be anything, and the returned value doesn't have to be y, it can be anything. Okay, that's the point. Now at this point, I want to draw your attention to a couple of facts. The first fact is that variables defined inside a function are valid only within the function. So they cannot be observed nor modified from outside the function. Let me explain. For example, we have just used this pay function here. We've just used pay function, and there's z inside this function. So R must have computed the value of z. But you don't see any z on the list. So here is the list of all the variables and functions we have created so far. We don't see any z. variable z does not exist. If I type in the console, if I type A1 or A2, R says what their values are, but if I type z, R says there is no z. And this is again because z is a local variable. When you call a function to use, when you call this pay function, z is created and computed, but as soon as the call of the function is over, z is released and disappears. It makes sense, right? If this is not the case, there would be a lot of confusions and errors. I mean, there are many functions, some of which were made by other people. Floor, ceiling, round, mean, max, mean, standard, deviation. We want functions to be useful black boxes. We don't necessarily care what's going on inside the functions. You use functions you made in the past and also functions made by other people. And also you use many variable names, and these functions also use many variable names. There may be variables of the same name, and names might clash. Okay, we don't want to worry about what variable names other people used when they created their own functions. So for that reason, variables created within a function are not observed from outside the function. So this z is valid only within this function. This z cannot be observed nor modified from outside the function. Okay, does that make sense? Now, here's the second fact I want to raise, and that is while the local variables inside a function cannot be observed from outside the function, in R, the variables outside the function can be observed from inside the function. Let me explain. To understand this, let me modify our code. So instead of directly specifying the tax rate, let me create another variable named tax rate. Okay, tax rate, and I say the tax rate is 0.05. Okay, I substituted it. Let me run. So tax rate is 0.05, and instead of directly specifying the tax rate inside the function, I say z is price times 1 plus tax rate. So for this function, this tax rate is a parameter. It's neither defined within the function nor is given as an argument. I have changed the code, so let me rerun the code. And now I type P1 is pay of price 1,000 yen. Let me run. Now, what happens is that when I use this function, when I call pay function, so price is 1,000, so 1,000 is given to this function, and R tries to compute z. Z is price, which is 1,000 times 1 plus tax rate, but tax rate is not defined within the function, so R searches for tax rate, and tax rate is here, it's 0.05. So the function computes z as 1,000 times 1 plus 0.05 and returns 1,050. So P1 is 1,050, as actually you can see that here as well. So we cannot observe z from outside because z is only valid within the function, but from inside the function, this outside value, parameter, can be observed. Now, suppose the VAT rate changes from 5% to 8%, and I want to recalculate the amount to be paid. So I type tax rate is now not 0.05, it's 0.08, 8%. So how much should I pay to buy something that originally cost 1,000 yen? Before, tax rate is 5%, now it's 8%. I'm going to buy the same thing, which costs 1,000 yen before tax, how much should I pay? That's the question. I don't have to redefine the pay function. Pay function is already defined here. Yes, the value of this parameter, tax rate, has been changed, but when I define a function and run the code, R does not check all the parameter values. When I define this function, R does not check what tax rate is. Only when I call a function like this or this does R look for the value of tax rate. So if I run the whole file, the first time I use pay function, R checks the value of tax rate. It's 0.05. It returns 1,050 yen. Okay. Now the second time the function is called, again R checks tax rate. Now this time the tax rate is 8%, so R computes Z using tax rate being 0.08, and that's why this function returns 1,080 yen this time, so P2 is 1,080. Okay? Now, let me explain how to define a function with multiple arguments. So far, we just gave one number as an argument, but this time we want to give two numbers. As an example, let us create a function that calculates body mass index, or BMI. That's a measure of obesity. BMI is your weight divided by your height squared. So you need to give two pieces of information. You give weight and height, and the function returns your BMI. So I think that's a very good example. Now for that purpose, I name the function BMI, and it is a function of two things. So I give two arguments separated by comma. Say W and CM. Open the braces. I can give a friendly comment with a hashtag symbol. So after hashtag, you can give any comment. So I say W is weight in kilogram. CM is your height in centimeters. And BMI is weight divided by height squared, but the height for BMI should be in metered. So I say H is height in centimeters divided by 100, and this is just to convert the height into meters. And after that, BMI is simply weight over height squared. Return BMI, and that's it. I run the code. Okay, now this new function BMI is on the list, and I can use it. Okay, BMI 60 kilograms, 170 centimeters. The BMI of such person is 20.7. That's how you make a function with more than one argument. But actually, there is a similar but slightly different way to achieve this, and I want you to know it. So in this method, before passing on multiple pieces of information to a function, in this case weight and height, you bundle them into one variable, creating a vector. Okay? So let me show you. I give a different name. This time, I name the function BMI2. And BMI2 is a function of, let's say it's a function of just x. Okay? Open the curly brackets. It's a function of x, but assume that x is a vector that contains weight and height information. And let's rename them. Let's say the first component of this argument x is your weight information. So I rename it as W. And the second component of this argument should be your height in centimeters. So I again rename it as cm, and after that the rest is the same as before. So I copy and paste this part of function BMI. Okay, this part is exactly the same. And I run the code. Now this function BMI2 is created. This is a function of x. And after that, I can create a vector of weight and height information. Let's say info is a vector of 70 and 180, so 70 kilogram and 180 centimeters. And what is BMI of such a person? So BMI2 of, BMI2, and I pass on this information. Okay, this is info. And this is the BMI of such a person, 21.6. Now note that if you type BMI2 of 70 kilograms, and 180 centimeters, it returns an error, unused argument 180. And this is because function BMI2 only accepts a single argument. So you have to put your weight and height together like this. So BMI2, so you have to put together 70 and 180, and then BMI can be calculated. Okay? Okay, finally, let me explain how to make a function return more than one value. As an example, let's create a statistic function that computes several things for you. So let's say x0 is, again, 10 different draws from the uniform distribution, and let's say the function name is myStat. As I label the argument as x, and here is the description of the function. I find the minimal elements of vector x. I compute the average of all the elements of x. I find the maximum of x. And finally, I compute the standard deviation of x. Now I put them together into one vector, say y, and return y. I run the code. x0 is this vector of 10 numbers, and I can use my stat x0. So here is the minimal value, and next is the mean, and next is the maximal value, 0.804. Yeah, here you go. 804 is here, that's the maximum, and the standard deviation is 0.258. Okay, so this function is returning not just one value, it's returning a vector of 4 numbers. And this is how you return more than one values. You should put them into one vector and return that vector. And that's, I guess, all you need to know about creating and calling functions for now.